Hi everyone, this is Mrs. Rondo and I'm going to be walking us through our lesson on rotations. We have two learning intentions today. I'm learning how to draw an image of a figure given a pre-image and the angle of rotation. So a lot of those words we should already know from previous transformations. We do have this idea of angle, which is going to be a review term, but angle of rotation is a little bit new. And then I'm learning how to specify rotation angles given a pre-image, image, and the center of rotation. For our purposes, our center of rotation is always going to be 0, 0 in geometry, which is the origin, by the way. Our success criteria, I can determine which rule to use for a rotation based on the given angle of rotation. I can apply a rule in coordinate notation to perform a rotation. And finally, I can determine the angles of rotation for a transformation given pre-image and the image. So we're going to jump into all that. Here we go. First of all, rotations. A rotation is a transformation where every point and its image are the same distance from a fixed point. I do realize you need to write that down, so maybe pause the video and write it down. And then here we have this phrase, same distance from a fixed point, which is actually basically the definition of a circle. And rotations are all about a circle rotating around a circle. So that's pretty convenient. Then we have our rules, which again, you're going to need to pause and write down. So our angle of rotation determines what rule we are going to use. And there is a thing here as well. You'll notice some of these, 90 and 270, have this nice long word counterclockwise, which I'm abbreviating with CCW, so I don't have to write it the whole time. And so we definitely need to know what is counterclockwise and what is clockwise. So really quickly, if I have a clock, basic numbers here, clockwise is when we go in this direction. That is what we call clockwise. And if I go reverse of that in this direction, that is what we call counterclockwise. So that's what we're referring to, kind of like going to the right for clockwise or kind of going left for counterclockwise. When we only go 90 degrees clockwise, that is actually the same, and I didn't leave space for this. I gotta erase my work here, that's all right. 90 degrees counterclockwise is going to be the same as going 270 degrees clockwise. So you can jot that down as well, 270 degrees clockwise. And then 270 degrees counterclockwise is going to be the same as 90 clockwise. And I'm going to do a quick little graph to show us how that works. So if I go counterclockwise, well, I went too far. Sorry, I went too far. Let me try that again. If I go counterclockwise, 90 degrees, so there's 90 degrees counterclockwise. That's the same as if I started in that same position here and I go in the opposite direction, I would end at the same place by going 270 degrees clockwise. So those two start and end at the same place, so we can use the same coordinate rule for those rotations. All right. 180, notice, and 360 do not have directions because you can go either direction, clockwise or counterclockwise, and you will start and end at the same place. So those we don't have to specify what direction because they end up working out the same. Okay, so on a graph, we have our good old X and Y axis, and we have our quadrants, which you may or may not remember how those get numbered. We use Roman numerals to number them, starting with quadrant 1 in the upper right-hand corner. This is our positive quadrant. Then we go backwards in a circle, or what we call counterclockwise, to quadrant 2, quadrant 3, and quadrant 4. That will become more important later, but I do want to remind us of those. Our quadrants are numbered in a counterclockwise fashion from here going all the way around counterclockwise, and that is in fact what we mean by counterclockwise, going all the way around the circle, kind of backwards in a circle. Everything in this is based off of starting at the x-axis. So if I start here at the x-axis and I rotate 90 degrees counterclockwise, I would end at the y-axis. That would be 90 degrees of rotation. If I continued to rotate further, all the way back to the x-axis, now I've gone 180 degrees. And if I continued further to rotate around, now I've gone 270 degrees. And again, if I continue to rotate one final time, I end up back where I started and I have gone a full circle or 360 degrees. So that's kind of how rotations work. Let's jump into an example. So when we are given, first we are told, draw the image of the figure under the given rotation. If I look at this, I have triangle PQR, it's on the graph, and I have an angle of rotation. If they do not tell you what it is, it's always going to be counterclockwise. So we are always going to do counterclockwise if they do not tell us. So from that, I'm going to grab my rule, x, y, turns into, and here's where we are going to go back and peek at our rules that we just wrote down. 90 degrees counterclockwise is that first one, so I'm going to be using this rule. X, y turns into negative y, x. All right, so let's see. Forward, that's going to be negative y, x. Awesome. All right, so I'm going to grab my ordered pairs. P is located at 2, 1. Q is located at 4, 1. R is located at 4, negative 3. And we are going to apply the rule. So here goes. If I apply the rule tells me do a negative, and then the y value, comma, and then tell me what the x value is. There we go. If I simplify that, I get P prime is at negative 1, 2. Then, if I do Q, again, the rule tells me do negative and the y value, and then the x value. And so I get Q prime at negative 1, 4. Finally, one more time with the rule, I take a negative and the y value, and then I copy down the x value. When I do that, I'm going to get R prime. And a negative means I really have positive 3, and then I have my 4. Okay, so we're going to go ahead and graph those points. We have P prime is at negative 1, 2. We have Q prime at negative 1, 4. I'm going to put P prime here. Negative 1, 4. And R prime at 3, 4. Then we connect the dots, and we have done the rotation. Let's go forward. All right, so this one, we have a quadrilateral this time. We have degrees of rotation. Again, if it's not there, we're going to do a counterclockwise direction. And so here I have x comma y is going to turn into, I'm going to sneak back to my rules so I can look at them. 270 counterclockwise means I'm following this rule, which is y negative x. All right, so let's go back forward, y negative x. All right, so again, I'm going to need my ordered pairs. I'm going to start with D, which is at negative 3, 1. I have E at negative 1, negative 1. I have F at negative 1, negative 4. And G at negative 3, negative 3. All right, so I'm going to apply the rule. The rule tells me to do y negative x. So I'm going to do my y value, the negative, and my x value. When I simplify that, I get D prime at 1, positive 3. Remember, negative, negative 3 really just means a positive 3. All right, let's try E. I'm going to do, again, my y value, which is negative 1, and then negative and my x value. So E prime, I have negative 1, and then negative, negative means positive, so I get a positive 1. All right, then I do, again, the y value, and then negative and my x value. And when I simplify, again, negative 4 here, and then negative, negative 1 means a positive 1. Finally, let's do G. Again, my y value, then negative, and the x value. I get G prime at, let's see, negative 3, then negative, negative means positive 3. let's put those points on the graph. I have D prime at 1, 3. I have E prime at negative 1, 1. Can't really see the prime there. Let me fix that. And then F prime at negative 4, 1. Negative 4, 1. F prime. And G prime at negative 3, 3. So there's G prime. Connect the dots. And there's our rotation. Awesome. All right, let's move forward. This time we're going to be writing the rule in coordinate notation for the rotation shown, and we're going to describe it in words. So here goes. To write the rule, there's a couple ways we can go about it. We're going to start with our pre-image, which is this one on the left, and I'm going to just pick a point. I'm going to pick D. And we know it's a rotation, so I want to write the rule for a rotation. So I'm going to do counterclockwise as my direction because that's our default. So D is going to turn into D prime. So those are the 2 points I want to compare. So I'm going to say D is at negative 4, 2. And that turns into D prime at 4, negative 2. So I'm going to try and write the rule based on this ordered pair and see what I can figure out. Well, it looks like 4 and 2 stay in those positions, 4 and 2. That means my X and my Y are going to stay put. But I do see that my negative 4 in the X becomes a positive 4. So that means change the sign. We show that by putting a negative. So my X value changes, so I put a negative to show it's changing. Same thing for the Y. I see positive 2 turns into negative 2, so a negative Y to show that it's changing. There's our rule in coordinate notation, and we can actually check our work by identifying the type of rotation. This appears to be 180 degrees, which we don't have to say a direction, we just say 180 rotation, and we can verify by checking the rule that that does in fact match the rule for a 180 rotation. All right, let's check out this one, same kind of thing. I'm going to start with R, and I'm going to turn to R prime, and again I'm going to keep doing that counterclockwise direction because that is our default. This time I'm going to see if we can name the rotation first. So I already said I'm going to use counterclockwise rotation, and we're going to try to figure out how far we went. It doesn't look like we went very far. It looks like kind of shifting that or rotating that triangle a quarter turn or a 90-degree turn. So that is a 90-degree counterclockwise rotation. I can check out the rule. I start with R at negative 4, comma 3, and that turns into R prime at negative 3, comma negative 4. So I could just look up the rule. We do have the rules for you. You can check it out, but I feel like it's good for us to try to put it together ourselves. So here, if I try to figure that out, it looks like this time my values are switching places. I start with a 4 in the X spot, and it moves to a 4 in the Y spot. I also have the 3 changing spots from Y to X. So it definitely looks like my X and Y values are changing places. And then I need to see if there's any change in positive or negative. So my original X goes to the Y spot, and it does not change. It stays negative in both. So my original X that started in the front and went to the back is just going to stay. It's just going to be X. Then my Y, when I check that one out, I go from a positive to a negative, so my Y value is changing signs. So my end result here would be negative Y, comma X, and like I said, you can go back and verify that that matches the rule. That does finish the notes. Take a look at those success criteria. I can determine which rule to use for a rotation based on the given angle of rotation. That would be looking at your rule table and deciding which rule to use. So if you feel like you got it, check it off. Otherwise, circle it. And then our next one, oh, that was, by the way, examples 1 and 2 for that one. The next one, I can apply a rule in coordinate notation to perform a rotation. That was examples 1 and 2 where we applied the rule. The next one, I can determine the angle of rotation for a transformation given pre-image and the image. This one would be what we did in examples 3 and 4. Again, if you've got it, check it off. Otherwise, circle it. And that finishes our notes for today. Please double check Google Classroom for assignments, and I will see you guys next time.